Let us look at proposition number 61 of book 10 of Euclid's Elements. The proposition says the square on the first bimedial straight line applied to a rational straight line produces as breadth the second binomial. So here AB is a first bimedial straight line and the square on AB is applied to a rational straight line DE. So when we apply that square on AB to DE, we get a breadth DG. And the proposition says that DG is going to be a second binomial. Okay, let's see how we can prove this. Let AB be a first bimedial straight line divided into its terms at C with AC greater than BC. Set out DE a rational straight line and apply a parallelogram DEFG to DE equal to AB square. So this produces a breadth DG. And what the proposition is saying is that DG is a second binomial straight line. So now we apply a parallelogram DH equal to AC square to DE. We apply a parallelogram KL equal to BC square to DE. We actually don't apply it to DE itself. We apply it to KH, but KH is equal to DE. So it is as good as applying it to DE. Since DL is AC square plus BC square, the remainder MF is equal to 2 times AC by BC. Now we bisect MG at N so that MO is equal to NF is equal to AC by BC. Remember, AB is a first bimedial straight line. So we know if a line is a first bimedial straight line, then its terms are medial straight lines commensurable in square only. And the rectangle contained by them is rational. So which means AC square and BC square are medial. That means their sum is also medial. And the sum AC square plus BC square is nothing but DL. So DL is also medial. Now this rectangle DL is applied to a rational straight line DE. So this area is medial, DE is rational. So that means DM is rational and incommensurable with DE. Okay. Now AC by BC is rational. That means 2 times AC by BC, which is MF, will also be rational. And MF is applied to ML, which is equal to DE. So which means MG is rational and commensurable in length with ML. MG is commensurable with ML. Why? Because MF is applied to ML and this area is rational and ML is rational because DE is rational and they are equal. So that means MG is rational and commensurable in length with ML, that is DE. That means DM is incommensurable in length with MG. How did this come? Because DM is rational and incommensurable with DE. And MG is commensurable with DE. So when we combine these two, we get DM is incommensurable in length with MG. So DM and MG are rational and commensurable in square only because they are incommensurable in length and commensurable in square. That means their sum, that is DG, is binomial. Okay, so we have shown that DG is a binomial. Now we have to show that it is a second binomial. So AC by BC is the mean proportional between AC square and BC square, which means MO is the mean proportional between DH and KL, because MO is AC by BC, and AC square is equal to DH and BC square is equal to KL, which can be written as in proportion form as DH is to MO as MO is to KL. Means DH, the base DK is to the base of MO, that is MN, is equal to MN, which is the base of MO, is to KM, which is the base of KL. So which means DK by KM is equal to MN square. Okay, we have reached this stage. Now, AC square plus BC square is greater than 2 times AC by BC. We have proved this in the lemma. Now, that means AC square plus BC square is DL. 2 times AC by BC is MF. So DL is greater than MF, which implies that DM is greater than MG. DK by KM is equal to MN square, which is 1/4 of the square on MG. You have MG square, which I have not drawn. MG square. N is the midpoint of MG. So MN square will be 1/4 of MG square. And based on a proportion which we have already seen, it means that DK is commensurable with KM. So, which means DM square is greater than MG square by the square on a straight line commensurable with DM, because DK is commensurable with DM. And MG is commensurable with DE. So, that means DG is a second binomial straight line. That was proposition number 61 of book 10 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.